get to spend enough time on the second part of the 3.2, 3.3 lesson in class. I am recording a video for the 3.3 section, so the second side of your notes. So hopefully this is helpful if you guys were a little bit confused. So 3.3 is dealing with the converse of all the theorems and postulates we talked about before. So the first thing is the converse of the corresponding angles postulate, and that says if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So this, remember, converse means reverse, and this postulate was just flipped around. So in this situation, you are given corresponding angles that are congruent, and therefore you will be able to conclude that the lines are parallel. Now, this is helpful in situations where we need to identify parallel lines, or even in a proof where we are trying to prove that parallel lines exist. The converse of the ulterior angle theorem, or alternate interior angle theorem, says if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So congruent alternate interior angles will give you parallel lines. Converse of the same side interior angle theorem says if two lines are cut by a transversal and the same side interior angles are supplementary, then the lines are parallel. So if your same side interior angles are supplementary, then your lines are parallel. The converse of the perpendicular transversal theorem says in a plane, two lines perpendicular to the same line are parallel. So this one, I'll draw a little diagram for you here. Two lines perpendicular to the same line. So you'll have one line and a line that is perpendicular to it. What this theorem is saying is if there is another line that is also perpendicular to it, then these two lines will have to be parallel to each other. So that's what that theorem is saying. And then the three parallel lines theorem. This says two lines parallel to a third line are parallel to each other. So if you have three lines, we'll say line A, line B, and line C. Okay. So two lines parallel to a third line are parallel to each other. So in this situation, let's say I told you that line A was parallel to line B. Well, then let's say I also told you that line C was parallel to line B. In this situation, you want to think transitive property, and if A is parallel to B and B is parallel to C, then all three of them are going to have to be parallel to each other. So, and we could actually write that as A parallel to B parallel to C. Then the next two theorems, they don't really have names, they're more just descriptions. Through a point outside a line, there is exactly one line parallel to the given line. So what this is saying is if you have a line and a point outside of that line, then there is exactly one line that could go through this point that would be parallel to that given line. You can also follow this same logic with perpendicular lines. Through a point outside a line, there is exactly one line perpendicular to the given line. So if you have a line and a point outside of it, there's going to be only one line that can go through this point that would be perpendicular to the original line. And then our examples. Number one said state which segments are parallel, state which postulate or theorem justifies your answer. So in a diagram like this, you want to kind of envision that all these segments, they don't actually end. Think of them as extending. It makes it a little easier to look at. So I'll even kind of draw over this, that line LA extends, line LS extends, It just makes it a little bit easier to see all your transversals. Just a recommendation here. Okay. So keep in mind all of these are going to kind of extend. So look for your angle relationships, right? You want to look for either congruent or alternate interior, or I'm sorry, congruent or supplementary angles. Now, if you look at angles 46 and 46, you might go, oh, those are congruent, right? And if you take a look, they're formed by, our transversal here would be line AT, right? Because 46 is formed by AT and LA. And this 46-degree angle is formed by TS and LA. So these are technically same side interior angles. However, they are not supplementary. And that is why line LA and line TS are certainly, line LA and line LT. I said that wrong the first time. This 46 is formed by TA and LT. So because these are congruent instead of supplementary, that's why these lines here aren't parallel. Okay. Then here with this 46 and this 44, you would maybe have alternate interior angles, but they're not congruent. So we won't have any parallel lines here. However, if you take a look, here 46 plus 44 is going to give you a right angle in that corner. We also have a 90-degree angle here. So if we have a 90-degree angle and a 90-degree angle, 90 plus 90 is 180. And on this side here, we actually are going to have same side interior angles that are supplementary. AS would be your transversal that cuts through line LA and line TS. So we are going to say that line LA is parallel to line TS, and that is by the converse same side interior angle theorem. Okay, because we had supplementary same side interior angles. Okay. Now take a look at number 2. In a diagram like this, we could potentially have a lot of different angle relationships. Like for example, if you take a look at angle 7, right, with angle 2, those are your alternate interior angles. And you have those in a few different places. Maybe we have some same side interior angles if you combine 7 and 8 and 3 and 4, things like that. So let's take a look at what we're asked. We are told that angle 1 is congruent to angle 8, and which lines would have to be parallel if that is the case. Now, this is actually a really great time to use that little strategy I explained to you guys with the symbols, the letters. Alternate interior angles are going to form like a zigzag type of Z shape. And if you take a look here, angle 1 is formed by line PL, or segment PL and LA, right? PL and LA. Then angle 8 is formed by LA and AR. So in this situation, LA would be your transversal, PL and AR are the lines that are being intersected, and if 1 and 8 are congruent, then PL and AR are going to have to be parallel, because you're going to have congruent alternate interior angles. So PL is parallel to AR. Now the next one, angle 5 is congruent to angle 3. Angle 5 is formed by line PL intersecting with line PR, and angle 3 is formed by line PR intersecting with line LR. Now angles 5 and 3 here are actually same side interior angles, because PR would have to be your transversal that intersects both PL and LR. And they're both kind of to the left and below your transversal. So these are same side interior angles. However, it's not telling us they're supplementary. It's telling us that they're congruent, and therefore we're not going to have any parallel lines for this situation. So no parallel segments. All right, angle 2 and angle 7. 2 and 7. So here, angle 7 is formed by segment PA intersecting with segment AL, and angle 2 is formed by segment AL intersecting with line LR. That means AL is your transversal that intersects PA and LS. And if you look at these are on opposite sides of the transversal. They are inside on the interior of the two lines. So that means line segment PA would have to be parallel to LR since these two angles are congruent. These are alternate interior angles. So since our alternate interior angles are congruent, segment PA would be parallel to segment LR. Then for part D, we are told to look at the measure of angle APL. So APL, that is this whole angle here, and angle PAR, that's this whole angle here. Okay. And it's telling us that these are going to have a sum of 180 degrees. So these are supplementary. So we need to decide, are these same side interior angles? And because if they are, then they'll be supplementary and we'll have parallel lines. So angle APL is formed by segment PL intersecting with segment PA, and segment PAR is formed by segment PA intersecting with segment AR. So if you take a look here, our transversal would be segment PA because it intersects with PL and AR. And since these two angles are going to have a sum of 180, they're supplementary, which means that these are same side interior angles that are supplementary, and segment PL will be parallel to segment AR. And then the last one for these, it's saying that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 5 plus the measure of angle 6 equals 180. So in other words, what this is saying is if I take the sum of angles 1 and 2 and the sum of angles 5 and 6, we're going to end up having 180 degrees, or therefore supplementary angles here. So the way you kind of need to look at this, because they're having you look at a bunch of individual angles, think like angle addition postulate. If you combine angles 1 and 2, you're going to get this full angle down here, angle PLR. And if you combine angles 5 and 6, you're going to get angle LPA. So in this situation, you have the sum of angles 1 and 2, that's formed by segment PL intersecting with segment LR. And then the sum of 5 and 6 is formed by segment PL intersecting with segment PA. So you have your transversal PL intersecting segment PA and intersecting segment LR. You have supplementary angles here because they have a sum of 180. Therefore, these are going to be supplementary same side interior angles. And therefore, segment PA is going to be parallel to segment LR. So hopefully that helps with that one a bit. The next thing we are going to look at is number 3. It says solve for X and Y. Something that's missing from our labeling here is we are going to go ahead and say that these 3 lines or segments are parallel. And what we actually have here is an angle relationship. We have same side interior angles with 120 and 2x plus y. And we also have same side interior angles with 2x minus y and 140. And if our lines are parallel, then our same side interior angles are going to be supplementary. So that's how we're going to set up our equations. Now, hopefully you notice we have two different variables. If you have two different variables within one angle, that is a big indication that you're going to have to solve a system of equations. So let's go ahead and just write our equations, and then we'll take a look and remind ourselves how to solve a system. So for this top one, we're going to, our two angles would be supplementary, so we're going to do 2x plus y plus 120 equals 180. And we're going to go ahead and when we do a system of equations, we like to have all our x's and y's on one side and then all our constants on the other side. So I'm going to leave my 2x and my y where they are, and I'm going to subtract my 120 over to make this a 60 on the left, or on the right, I'm sorry. Then on the other side, we are now going to take 2x minus y plus 140 equals 180. And we're going to follow that same strategy, 2x minus y. I'm going to subtract my 140 to just get 40. Now, when you solve a system of equations, you can either solve them by substitution or elimination. Hopefully that sounds familiar. These are set up to solve by elimination. That's probably the most convenient way. So what you do with these is you take your two equations, and we are going to rewrite them one stacked on top of another so that we can do our elimination in order to solve. So let's rewrite this. We're going to have 2x plus y equals 60. And then we're going to have 2x minus y equals 40. Now, when you do elimination, you're looking for a variable to literally eliminate, either by adding or subtracting. I like to look for opposite signs because negatives, like if negatives and positives will cancel each other out. Like right here, if you have a positive y and you subtract out a y, those are going to cancel each other out. Or here, you could cancel a 2x and a 2x, but you're going to have to subtract this entire equation, which means you're going to have to switch your signs on the y and the 40. So let's focus on the ones that already have opposite signs. So what I'm going to do is just go through and combine my terms. I'm basically going to add this. So 2x plus 2x is going to give me 4x. Y minus y is going to cancel. And then 60 plus 40 is going to give me 100. Then divide by 4 to get 25. And that's actually one of my answers. That would be my x value. Then to get y, I just have to plug it back into one of my original equations, either one that I like. I prefer to work with positives. So I'm going to plug it into 2x. So that'd be 2 times 25 plus y equals 60. 2 times 25 is 50. And I'm going to subtract that over to get that y equals 10. Now, in a standard system of equations, you do write your answer as coordinates. This you do not have to because we're not solving on a coordinate plane. We're solving values for angles here. So you don't need to write your answer as a point. All right, so hopefully this helped with this portion. Let me know if you guys have any questions.